it over to our hosts for today, Lee and Franco.
Thank you, Karen, and welcome to another awesome episode of Data Collab Lab. I know it's going to be awesome because we have chocolate involved, and why not? I'm a solution architect here at Databricks. Before that, I spent a lot of time doing data engineering, and I can remember stumbling upon the Hive functions when I was working with Hive a lot on how to do a lot of nested manipulation of my data. And I can remember just never actually getting it to work for whatever reason, actually like trying to write that code and then maybe even running it on a large data set. I found that the performance just wasn't there. So I'm really, and then I had to step back and actually write MapReduce code. So I am really excited today to see what these guys have in store for us and show us what we can do with Spark functions to unnest our data and work with it. And how about you, Franco?
Yeah, thanks for that, Lee. Yeah, my name is Franco Patano. I'm a solutions architect with Databricks. My background is actually data warehousing and BI. One of the and today nowadays I spend my time helping customers figure out what Lakehouse is and how it fits into their architecture patterns. One of the things I agree has been really hard in my career as an analyst and as managing data in general is like how do you work with these complex nested structures, or how do you deal with dimensionality inside of your data objects? And I am really excited today to bring Fred and Chengyin here, who are going to take us through these examples and show us how we can do these things in Spark SQL on SQL Analytics. With that, Chengyin, do you want to introduce yourself?
Yeah, sure. Hi, everyone. My name is Chengyin. I'm from Chicago. I'm a data scientist. I usually split my time between delivering machine learning trainings and also implement data science solutions for customers.
And Fred, how about yourself?
Awesome. Yeah, thank you, Lee. My name is Fred Aboud. I'm a solutions architect here in Chicago, working with Franco on the enterprise team to help clients figure out what Lakehouse is and how it can solve a lot of their data problems. I have a background in SQL as well as Python. So I guess we can kick it off here.
Awesome. Wow. So you guys are, everyone here except for me is in Chicago. Even though we're connected by this awesome lab background, you guys are actually close together.
You need to move, Lee.
San Diego is not so bad.
I think we need to go there. We need to have an episode over by where Lee is. I'm thinking when it gets colder, like in the fall or winter, maybe.
Absolutely.
Maybe we'll have a follow-up to this episode in California later this year.
Yeah, and Fred, as you start to share your screen and all that, I just want to call out, please post any questions in any message format where you are. It might be on LinkedIn, it might be on YouTube, or in the Zoom, and we're here to answer them.
Awesome. Can everybody see this okay?
Yep.
Cool. So we're just going to get started here in SQL Analytics, which is Databricks SQL development environment. We can jump in and check out all my queries. And we can see I've favorited all the queries that we're going to run through for this demo today. Jumping in here, it's really easy to share your queries in SQL Analytics. I can just grab someone from my team. Now Franco can run this as well. We can edit the code. We're just going to get right into learning about arrays and structs. So there's a few different types of data structures that we have in Spark for nested data. And the primary one that we're going to work with is arrays, which are just a list of values that allow us to add dimensionality to our tables. So we can have this list of different types of chocolate that's contained in one row rather than having it contained as a column. And as we think about what we might want to do with that, one of the first things we're going to do is need to actually take data out. And you can see here, whoever wrote this didn't necessarily format it very well. So we can just format that real quick. And we can arrays in Spark are indexed starting at 0. So we can run this. And you can see this is how we're going to grab a couple items out of that array. We could go all the way through to, there's 3 items in this array, so we could go through to item number 2 to grab all of them. If we wanted to say, figure out what position the word dark is in that array, we can use this array position function, which is going to return the one indexed position of that item, so it's in the second position. And there's actually a ton of really useful array functions pre-built into Spark. So we can, for example, find the min and max, or figure out if like an array contains a value or if two arrays overlap with one another. And in general, there's two different ways that we can think about functions that operate on arrays. There's functions like array contains and arrays overlap, which verify something or check data in an array and then return a Boolean whether or not the thing we checked is true or false. And then there's functions that manipulate the array or transform the array, like the min and max or arrays intersect, which obviously find the min and max, and then arrays intersect compares two different arrays like a Venn diagram and pulls out the items that are in both arrays and returns that as a third array. If we wanted to see what all the different array functions are, we can just quick, I'm not going to spend a ton of time on this. I just want to call out that the Spark documentation is great, and we have a whole slew of functions here that we're not going to be able to get into today, so that you can really perform whatever operations you need.
So typically would, like, if you were in Python, there would obviously be
Yep.
like functions inside of pandas to be able to do these same things.
Totally.
But when you work SQL only, and SQL Analytics is a product from Databricks where essentially it's only SQL inside of these SQL boxes. So what we're saying here is that you can do the same type of functionality that you would get inside of like existing like Python libraries, for example. Then you can enable functions with that same functionality working on the same data sets. Let's say that your data scientist would be using inside of Workspace as an analyst, then you can come in here and use these types of Spark SQL functions to get the same type of functionality.
That's a great call out, Franco. Thank you.
So what you're saying is this is not your mama's SQL. This is pretty powerful. Nice.
So the next thing we're going to check out is how we can explode an array. And if you think about an array as a list of values, it's not dissimilar from a column in a table. So what we might want to do is actually transpose the array so that we can represent it as a column rather than as a multi-dimensional table. And that's what this explode function is going to do for us. So we can see here, we've now transposed the array so that rather than having one row with an array that contains 1, 2, and 3, we have 3 rows where we have a column for the company that produces dark chocolate. So there's a lot of stuff we can do to sort of manipulate these data structures so that we can use them in whatever way we see fit.
That's awesome.
Moving on from arrays, the next thing we're going to talk about are structs. And a struct is just a key value pair where an array has an order, and we can grab the items based on their position in the array. Structs don't have any order, but they have key values. So here we have like call 1, and the value is 3, and the key for 3.5 is call 2. This is useful, but what's even more useful is this concept of a named struct, where rather than using call 1, 2, and 3, we are actually going to provide labels to each item in the array. Or to each item in the struct, sorry. So now we've named each of these values with like the number of bean types, the rating, and the bean origin. And then we can get information out of that named struct using dot notation. So this is sort of similar to if you would have done like a left join, and then you would have called on the table that you joined with a dot, and then the column from that join table, and we can say like s dot number of bean types to grab that item out of the struct.
Nice.
So it's like aliasing. It's essentially
exactly
the struct like an alias.
Yep. And you can even think about this like each struct or each named struct is like a row in a table where the column names are the keys for that key value pair. So then what we can do is create an array of named structs, and that's going to be very similar to a table where we have a list of these key value pairs, and you can see like each key value pair has the same like items in it, and then we just have a list of multiple key value pairs. So this is very similar to a table, and Spark actually provides this function called inline, which can convert the array of structs into an actual table. So we can query that here.
So
And
if
this is
I'm
just-
working, sorry,
Yeah.
I just got to ask you. So if I'm just working with if I get a big JSON file from someone, most likely I'm going to see structs in there. Like, would it be structs and arrays, a mix of it? Is that how you think about it?
So like a struct in general is very similar to an array, or is very similar to a JSON file where you have
Key
like
value.
values stored under keys. And then JSONs even have an array type as well, where you can have like a list of values stored within the dictionary structure of the JSON file.
Right. Okay.
So you can imagine, especially if you deal with a lot of JSON, how this could get very highly nested, depending on like whatever data you're working with.
So
Yeah.
does this mean that I don't have to like completely unnest all of my complex nested documents that I might get from all these different data sources that transmit in JSON? That means I could put SQL right on top of those structures, and I can query out. I don't need to do an
Yep,
extra step of
totally.
ETL.
You can just query the JSON directly using Spark, and that's where a lot of the built-in functions that I mentioned earlier come into play, because a lot of the things that you need to do commonly have already been built into Spark, so that you don't have to necessarily write like custom code to perform those operations.
We got a question from YouTube. Can you have an array of heterogeneous structs?
So I guess, what do we mean by heterogeneous? Where they're not all the same, and you have like, for example, different like numbers of key value pairs in each struct in the array.
Maybe.
I think arrays are going to be typed. So an array of structs will have to have structs that all have the same schema, so that the type is consistent. Otherwise, you could imagine, like, let's go back up here where we actually explode the array. If you were to explode this array and the structs would be of different types, we would actually have a column that had rows that changed types. So we want to prevent that from happening. So we have to be consistent throughout the array.
Makes sense.
Yeah, and just to add on to that too, it's quite common for us to see the struct to have the same type but different lengths as well. So later on, you will see that in the chocolate data set that we'll be using, companies can produce different brands or different types of chocolate, and you will see that there will be different lengths within an array or a struct.
Totally.
Got it. We have one more question, if you don't mind. And it's a question from Richard Katz around, are there control structures? And I think this is more general around SQL or Spark SQL. So he's asking, like, if blah, select blah, else select this. And I think this might go back to what you were talking about at the beginning, Fred, where there's some functions that you can look at as maybe those conditional checks. So for example, if array contains, chocolate, then select the explosion of that array, else don't select it. So I think I'm answering that question right here, but you all can add on to that. So absolutely, there are control structures, and some of those functions we were talking about lend into those control structures.
Case statements.
Oh, did we lose Lee? Yeah, I think, Franco, you took the words right out of my mouth. We could easily see how you could wrap some of these array functions in a case statement in order to say, like, case when array item 0 equals 1, right? Then do something else, do something else.
Right.
Cool. If we don't have any more questions, I will move on to the next section. Pop back into my favorites here, and we're just going to explore how we can actually create a nested data structure from a flat data set.
Okay.
So here we can just see we have this database of chocolate data, and we're going to use this reviews table so we can get a quick idea of the different columns and types of those columns in that left-hand rail. Additionally, we're just going to run this select statement real quick and see what this data looks like. And right off the bat, we can see that these columns can be grouped into different objects. So we have what looks to be like a company here. We have some information about beans. And then we also have some reviews of each bean for each company. So let's go ahead, and group these objects into structs so that things are just a little bit more logical in how we're referencing them. We're just going to create a table here. And then later on, we'll be able to query from that table easily. Great. So now we can check that out. And you can see here, now we have like this company struct, we have a bean struct, and then we also have a struct for each review. So in this scenario, every row in this table represents a review of a bean produced by a company. But what I'm sort of interested in at this point is to say, like, what if we want, like, let's look at, let's create a table where every row is a company and a bean, but I also want to be able to preserve the reviews within my data set. So here, what we can do is use this collect list function, which is going to aggregate our reviews into an array, and it's going to group it around the company and bean structs that we created earlier. So here you can see we have our companies, we have the bean produced by that company, and then we have the reviews. So this bean company combination had 3 reviews from 2016 to 2019. And this is what Cheng-Yin was mentioning, where you can have, even though the structs within the array have to have the same schema, you don't necessarily have to have the same number of structs within each array. So the next bean down only has 2 reviews, whereas the first bean has 3 reviews, but they all the reviews have all the same fields.
Hey, I think is it time to transition over to Cheng-Yin's part? Or
yep. Yeah, we can, we just have this one last query here where we're actually nesting it up one level further. And we have that original query here where we're nesting at the company bean level, and then we're going to aggregate the beans so that we have an array of the beans, which also contains an array of the reviews. So we have the company, and then we have beans, where each bean contains another array of reviews. So this is great because each row is a distinct company. So you can run a count one or count star on this table to get a distinct count of companies without having to do the expensive count distinct on the company column.
Awesome. This is great. While we're transitioning, I do have a couple of questions I wanted to address. Thanks for that part, Fred. Really appreciate kind of like the understanding of what arrays and structs are. A couple of questions that came up. Danny asks, can you just like do inline JSON file name? I do not think you can do that. It has to be a tabular object to use inline. But if you read that file name into Spark and then wrote it out as like a Delta table or something, you can then pass the table into the inline function, but it has to be a tabular object. And another question came up from Rajendra about what if you have JSON files that continually change their schema? Can we parse the schema of the JSON file? This is a great question. We do have a preview feature that actually does schema inference on these types of objects for JSON documents. Please reach out to us and we can talk to you about it privately. We can't talk about those types of features on the public cast, but we can definitely talk to you about it and how we solve that problem. And with that, Cheng-Yin, please take the floor.
And I'll just since it's kind of in my mind how this is structured is, or at least in my past, like as a data engineer, I might be needing to parse a JSON file that's coming in from something. So I'm typically trying to unnest a JSON file. But what we've just showed you is that the creation of nesting, some tabular data into JSON file. And I think now what we're going to see is the second half of that. How do we now take JSON and answer some questions with it? So just to think about it in that way, you can go two ways, right? You can nest it from SQL and you can also unnest it in SQL.
Yep, exactly. Thanks, Lee. So just now, Fred was simulating a role of data engineer. He was trying to get data and then putting data in the right place. And then now I have this nested data. So as an analyst, I would like to find out more about chocolate. So before I get into the queries, I just wanted to give you some background about this chocolate data set. So we got this data from the Kaggle website. We care about chocolate because the residents of the US collectively eat more than 2.8 billion pounds each year. So clearly, it's really important for us to know where to get the best chocolate. So you can see that there is going to be ratings that we'll be interacting with throughout the later of the demo. There will be 5 ratings, 1, 2, 3, 4, 5. You can see that the 3 represents satisfactory, 4 represents premium, 5 represents elite. And the rating here is actually a compilation of how good the flavor is and the texture, the after melt, which is really important, that goes into calculating the rating of the chocolate. So without further ado, let's dive back into the data. So just now, Fred was showing us how this nested data looks like after his transformation. So let's just take a look again to refresh our mind. So you can see that there is 3 columns right here: company, bean, and review. So what is weird about this display is that you can see, if I can expand this, this is a length of 2, it has 2 items in there, and then this has 4 items in there, but this doesn't quite display in the same way. I can choose to edit this visualization so that a consistent display format is being used. So what I can do is I can click here at the bottom bar right here, edit visualization. And now you can see that there is different columns: company, bean, and also review. So these 2 are already displayed as I desire. All I wanted to change is the review column. So I can click on this right here, this arrow button right here. And you can see that there is a functionality for us to change between different display formats. And since this is a JSON format, a key and value pair, I would like it to display as JSON. Now you can see that it's displaying as the same format as the other columns. Okay, so now that we've got that out of the way, let's look at the statistics of the beans. So you can see that right here, that I've commented out over here, I am interested in just looking at, for each company and for each type of bean, what is the average review rating and how many number of reviews we're actually getting for each bean. And then we can group by, and then we can further construct them into a struct. So I'm just gonna uncomment out all of this to run this query to show you what it looks like.
Just so that the users at home know what keyboard shortcuts we're using here, just can you review like how we comment, uncomment with keyboard shortcuts and how we execute with keyboard shortcuts?
That's a great question, yes. So you can see that all the comments here are, if I were to type something, select 1, I can choose to comment this line out by using command / if you're on Mac. And I can also use the same keyboard shortcut to uncomment it as well. And if I want to execute a line or a block, I can choose to click here, execute, but you can also use command enter to run the command as well. Okay,
thank you.
So now I'm just gonna select everything over here. And then just for the clarity's sake, I'm just gonna click on this, execute selected. So you can see that we can choose to limit the results to only the first 1,000 rows. And if we don't check that box, then it will return everything. So this data set is relatively small. So we don't have to worry about just limit to 1,000 rows for this demo. But now you can see that after grouping by just company and bin, we only have 2 columns, which is what we wanted. So I'm gonna expand this to show you what it looks like. You can see that this is a company, and now this bean, we can have for each of the company here, we have the bean type, specific bean origin, average rating, and also review count. So you can see that while this chocolate was rated as semi above satisfactory, but there was only 1 person who reviewed it. And same thing for the rest, you can see that for each company, there is a bin. So this is how we can choose to start to parse the nested review data set into information that's more digestible as a user. Okay, so now I'm sure that all of us are now wondering, what about bean info by company? Is there a specific company that produces the best chocolate or the best, that has the best after melt for a chocolate?
I'm very interested in knowing that. I would like to find that company immediately.
So let's look at this again. You can see that we are using the previous data. So chocolate bean stats, which is what we are creating over here, chocolate bean stats. So we will be working with data with company and also bean columns in this second query right here. So I am going to just uncomment this again by using command / and I'm going to run this. And some of you might be able to recall that this is actually a function that Fred was showing earlier. So just now, we are merely grouping by a company and also by a bean. So that means that we are not able to have the clarity into how many beans record there are actually for each company. So by using this collect list function, we are able to now see for each company, we are able to see 23 different items for this particular company, followed by 5 items, followed by 2 items, and so on. So again, this is where we start to see different lengths of structs can come into play when we're dealing with nested data. So again,
and a question on this then, if I wanted, you get 23 beans back in this particular row. If I wanted just to get the max bean rating from this particular row, is that where I could use another array function to get that?
Yep, exactly. You're right.
Okay.
Yeah, and later on, we'll actually be able to get some aggregate statistics and also sort of show how we can actually get, the most important information out of this data. Because right now it's still kind of hard to tell, like which company actually has the best chocolate or produce the most number of chocolate.
Yeah.
So here you can see that I start getting to this display format that is displayed as a string rather than JSON again. So if I want to change that again, I can go into edit visualization and I click on company. Oh, I keep doing this toggle visibility, but you can see that the arrow button is what you need here and display as JSON. So this will be able to give you that JSON format display that you need. Okay, so now let's start looking at some of the aggregate statistics. So these are actually just really common aggregations that you might already have been doing on your own data set, not just nested data, but also just flat data. So you can see that we have count over here, we have average, we have percentile, approximate, because in Spark, we don't actually implement the exact median just to save computational time. So it's always going to be approximate 50% to get a median. And there's going to be minimum, there's going to be a maximum. And something to note here is this function right here called size. So this is what is equivalent to length in Python. So we're able to calculate how many bean types, how many bean items are actually, available for this particular company. So let's look at this in aggregate across all company.
So I just want to make sure I understand that. So size is like elements in the array count. Is that correct?
Yep.
Yep.
Awesome.
Yeah, so it means that the size over here is able to give us the length for a list output from the previous form of data. So now here you can see that in this data set, we have 418 companies altogether. And on average, each company has about 4 types of chocolate. And the median is actually 3. So minimum right here is 1 and maximum is 47. So which can explain why probably the average is skewed towards higher value, because there is a company that is apparently really fruitful in terms of producing chocolate. So now I am really curious, which company is it that actually produced 47 chocolate? So let me just try writing a query over here. So I'm going to do a select from. So you can see that when I start typing, there's actually autocomplete. So I can, choose to just tap, click, enter. So not click, but, press the tab button so that I can finish the autocomplete, and then select star, and then from. So here will be the chocolate schema and then bean by company right here. So I use enter to finish autocomplete just now. And then now I want to calculate which company has the size of 47 beans. So here I'll be using size function again, size beans, which is the column name. And here I'll be just using larger than or equal to 47.
Nice.
So now I'm going to press Shift Enter or Command Enter again here. Then you'll be able to get the information about the company. So you can see that this company called Soma in Canada produces a bunch of chocolate types. I don't know whether any of you is from Canada, but now it makes me want to go try every single chocolate, which would take me almost a year if I would try one every week.
I could try them all in a day.
I trust you. Cool.
It's interesting. Canada, right? The land of maple syrup and chocolate. I wonder if they've got a sugar problem up there. A good problem to have.
Yep. And you notice that just now I made edits to this query. So if I want another person to be able to see the updated version of the query that I was writing, then all I need to do is to click Save or Command S to save this query.
Nice.
So now I think this is the finale, because we are now dying probably to know which is the best chocolate. I am a fan of dark chocolate. I do not like milk chocolate or white chocolate, even though I tolerate them. So this is a really important question to me. So here,
how dark? I'm curious. How dark do you like it? Do you like 90 percentile or like 70?
I wish I can tolerate 90%. I'm a solid 70% dark chocolate person.
We're cool. We're cool. All right, cool. All right.
Cool. Yeah, so you can see that so far we all have been manipulating with just by using create or replace table. And this is actually the recommended form of just creating or dropping tables rather than dropping and then create tables. So always use create or replace table. And now we are going to use something that you haven't seen before in this demo, but probably have used in other parts of your query writing, is CTE, which is Common Table Expression. So this is equivalent to how you will be able to write a temporary view of a table or just a view of a table without needing this to be saved in your schema. So we can take a look at this left sidebar over here. You can see that this is the schema that we have been using, chocolate. And we have been starting out with this reviews table. And after we use this create or replace table, now bean stats show up there, bean by company show up there, and there also nested review shows up there as well. So if you are, forgetful like me, then you can click into individual tables to check which table actually conceals the information that I need. So now we are going to do something a little bit different because I don't actually want this table to be persisted. So I just would like to use a Cte expression over here. So you can see that all I need to do is a with as statement right here. This will be the name of the table. And there will be the names of the columns that you're interested in. And here we are actually going to be using the first data frame that we saw before. So let me just run this query real quick, just so that we can all remember what this looks like.
By the way, while you're doing that, the reasons why you do create or replace table with delta is that object storage is eventually consistent. So you don't want to truncate, kill and fill, or truncate and load is an on-prem thing, does not work well in the cloud. That's why create or replace table is there. And then CTEs is the best way to get optimal performance out of SQL Analytics. So this is great that you're covering this. Really appreciate it.
Cool. So here is, now I'm just going to pretend that, I only have the nested data structure that is provided by Fred, and I have no information of the flat data frame that exists out there. So here's the data that I have to work with. So now all of this nested data, I have to figure out how to get the best chocolate. And you might think this is a really complicated task, but look at this single line right here. All I need is to use a dot notation to extract out all the fields from within each column. So by doing star over here, it is going to give me company and company location. By doing bean here, bean.star is going to give me all the field names that I need, the key names of this column right here, and the same thing with review as well, which is why I'm able to just select by the column names or by the field names, by the key names over here. So then I'm just going to comment out this line here and move on. So you can see that by just extracting this, all of the fields out using dot notation, now I can just proceed to writing my regular SQL, just like normal, just like this is not a big deal. This nested data is not a beast I thought it was. So here you can see that for each cocoa percent, because I care about chocolate percent and company, bean origin, and bean type, I can now get the average rating and also how many reviews they are for each of the ratings. So let's run this and take a, oh, I need to run the whole thing. Take a look at what the output data frame is. So now you can see that there is a cocoa percent, clean company, bean origin, some of them is blank, and there's bean type, average rating, and also number of reviews. I don't know about you, but I always don't trust when a restaurant or when a food only has one review. So I am going to filter them out. So say that I am going to just enlarge, make this filter number to be a bit larger. And since there is a lot of reviews for some of the chocolate here, I think I can go a little bit higher than 30. So let's just do, than 1. So let's just do maybe, I don't know, 50 over here. And then say that you're looking back at this Kaggle data source, I really don't want anything that is just satisfactory or praiseworthy. I want something premium or elite. So I'm going to filter them out as well. So let me just...
Let's just go for the elites already. Come on.
Okay, Lee, if you say so. Okay, let's...
Why would you want sub-quality chocolate?
Yeah, if there's 5s out there, I want to see all the 5s.
Okay, let's do anything that is larger than 4, which is 5. So let's run this entire thing again. Now I'm really curious. I actually haven't tried limiting into just elite. Oh, there's only 1. So that makes the choice easy. Okay, so
where
this
are we going?
It's called, yeah. Oh my gosh, I'm gonna be so bad at pronouncing this. So Amide, Venezuela, and Trinitario. Oh my gosh, I'm totally gonna keeping my eye out on this one. There are 78 reviews, which I think is decent, and average rating is 5. That is amazing.
Nice.
Okay.
So I'm going to take a swag that it's pronounced Amadai. If anyone from South America wants to correct me, but in the Latin languages, so I'm trying to pronounce it the Italian way because that's the language I know, but I'm pretty sure it would be pronounced Amadai. But if anybody knows out on the chat, let us know how that's pronounced.
Cool. Thanks, Franco, for rescuing me. As you know. Okay, so now there you go. Lee made it easy. So now we have this one final recommendation that we can all remember. It's from this company, Amadai, Venezuela, and Trinitario.
Nice.
With 70% chocolate, which is my perfect chocolate.
I like 70%. And I don't not like milk chocolate as much as you do, I guess. It's okay, but I agree. Milk chocolate is subpar to dark chocolate.
Thanks, Franco. Or else we might not be friends.
Well, that's awesome. Yeah. I just wanted to say too, I think there was a question earlier on just the availability of these functions, and just to level set that while we're running all of this in our product that you see here, SQL Analytics, these are available in the Spark product. This is just open source Spark, or even if you're running in a Databricks notebook, you can use all these same functions. And while they're continuing to be developed and worked on, and you're seeing some of these new sophisticated functions, I think they've been around, like the array explode and some of the other ones have been around in the Spark product for probably since 2.0 or more. So yeah. And if we wanted, that was actually a good question. If we wanted to do like higher level functions, we've got some documentation on how to kind of do more advanced manipulation on this as well. We'll link that when we send out the links to all of this stuff.
Great call out. There's a couple questions I think that we can address here. One question is, and something I want to call out here, Chengi, if you can help me out since you've got the screen. Somebody called out that I just want to make it aware, what are one of the tables that have nested structs on the metadata? Can you drop down one of them? I think like nested reviews or bean stats has nested structures, right? You can see here that it says it's a string, but it's not. This is something we're actually working on. This core product that is here is what's known as Redash. This is SQL Analytics is our version of the open source project Redash. It doesn't have the ability to inspect those types, but can you do a describe on nested reviews
yes.
inside of the window. So
Yep.
there you can see the types, and somebody called it out in the chat, like, can I do a describe command? You can absolutely do a describe command. When you do a describe, it tells you the right types. In the schema browser, though, it doesn't. It's a holdover from the previous version of the application, but we are actively working on it right now. You can run describe within the SQL window, and that will return the right types.
Nice. I gotta say, I've never seen a live demo go this well. Great job. Not one error.
Well, there were a couple, but that was because I think sub-selected text, non-complete text was selected, and then actually that's
So
the biggest
quick.
error that I did, is that you have like highlighted but not what you want to execute. You were like editing something in the SQL.
Mm-hmm.
What else we got? Other questions you're looking at, Franco?
Yeah, I'm figuring out how to address this one. So it's kind of got a couple different parts here. So somebody asks, how does caching work with inside of SQL Analytics? And there's a follow-up question too that I will address. But the question is there caching? And there is. There's a couple layers of cache inside of the SQL Analytics product. There is what's called Delta cache, which is on the cluster. And then there's also SQL Analytics cache, which is part of the application. So there's two layers of cache. And his follow-up goes on to kind of like, how do you actually integrate this into a production-like environment if you can't do like temp tables or temp views? You can absolutely do temp views. The best way to get the optimal performance is by using CTEs. And that's the best practice that I am more than grateful that Chengying architected today and kind of drawn out. But you can still make temp views. But as Chengying said earlier, that puts metadata into your metadata repository, right? Then that kind of creates like stuff that has to be cleaned up. If it's a temporary object, you don't really want to persist that. That's why CTEs are there. That does not mean you can't make temp views. You can absolutely make temp views inside of SQL Analytics. Any color that anybody wants to add to those questions?
No, I would just say that CTEs not only add to the performance, but just the readability. I mean, anytime I come in and I see a really largely nested query where it's like subselects and subselects, you can really simply, translate that into a CTE, move those subselects up to the top and then and then that helps for debugging, right? You kind of can comment out as each CTE, maybe you have changed CTEs going, you can, incrementally comment them out and check that they're doing what you need to do.
Yeah, and I also would just like to add that even though CTE here, we do have to pull it from memory, but caching also doesn't necessarily make it better because you're also storing data on memory as well. So that's just something to keep in mind when to think whether you need something like a CTE will work or whether do you actually really need to cache your data.
There's a great call out. One of the most popular performance issues that I get brought in to untangle is over caching. And typically I will remove like dot caches or caching mechanisms, and that speeds up data pipelines, which is counterintuitive. But the lesson here is don't over cache. Spark is actually pretty smart. Like the underlying mechanisms under Databricks, not just Spark, but Delta as well, like the Delta cache. These things are smart. You don't need to be as verbose or as explicit with your commands with caching. It will kind of recognize what it needs to cache under the covers. So don't be too aggressive with caching. This software is pretty smart nowadays.
Yeah, maybe one last important part I just wanted to call out is that we have posted all of the code here in this GitHub page. I believe that one of us will just follow up with you all to share this link, or we can also just drop this link right now. So you can see that there is two folders right here. One is the DBC file if you have a Databricks workspace. If you don't, you can just click into this folder and then just download the individual HTML file. Then you can just open it in your own browser once you download it.
Funny story. So someone posted a link of the chocolate that was found. It actually, the reason why I thought it was an Italian word, because it is an Italian word. It's actually from Tuscany. I don't know why it says Venezuela in there. Maybe there's a, but
the location in that data set is actually the company location versus Venezuela is the bean origin. So it's an Italian company producing a Venezuelan chocolate.
Got it. There you go.
I thought we had an issue of, garbage in, garbage out issues here. Good.
I think that's also why a Canadian company can produce so many types of chocolate, because I have a hard time believing there's a ton of cocoa plants growing in Canada.
Good point.
The other thing I think we wanted to call out in this session was that Spark has the ability to do Lambda functions if you really did need like a super complex operation on your arrays. There's like a lot of higher order functions. You can do filters and aggregations and write custom functions on the fly as well.
That's a great
Let's see, we have a couple other questions. Is it easy, from Austin, is it easy to collapse and change nested data's granularity? Someone want to answer this? I'm not sure if I totally understand the context.
If I were to tease that out a little bit more, like how I view that is like when we were talking about explode, how do I kind of transpose the nested structures, I think is what you're asking. How do I change the granularity? How do I transpose the structures? And I think we covered that with, would you agree with that kind of was what being asked here, and any additional color?
Yeah, that's sort of what I was thinking as well, is like you have the explode function if you want to like transpose an array into a column, and then you also have like collect list or collect set if you wanted to aggregate unnested data into a nested structure.
Mm-hmm.
So Richard asked about func tools and some other thing that I don't know if I recognize, but are there controls for caching? Yes. If you go into the docs, there's an extensive article about caching in Databricks and in general with Spark and with Delta. But you can, as simply as say cache select star from table where, and that'll cache like a subset of data. And you can kind of control some things in the cache there, but just like I said earlier, there's layers of cache inside the product, depending upon where it is. And if you have further questions on that, please reach out. But yes, you can cache directly. But like I said earlier, be careful when you cache, because sometimes you spend more time caching than you would have if you just processed the query. So just, proceed with caution.
Awesome. I think it's a good point to kind of wrap up. And if you guys have any more questions, reach out to us. You know where to find us. We're on LinkedIn, or just reach out to collablab@databricks.com. Is that right? Or Data Collab Lab at databricks.com. Do you know, Franco?
Data Collab Lab.
Data Collab Lab at databricks.com. And we will catch you later. No, that's my bad joke. Karen's going to take us home. So I'm going to pass it over to her.
We need a soundboard. Like fun sounds, like, but
my friend was saying that we need a little like a clap track.
Work on that next.
Yeah, I should research that. That'd be fun. But thanks, Lee and Franco, another great Data Collab Lab session. And thanks, Fred and Chengying. This was an awesome session and really fun topic, and awesome to learn about different chocolates. I had no idea that there are so many different options. So thanks everyone for attending, and hope you will join us for our next session. Join that Data plus AI online meetup group to check out more sessions. And I also dropped the link, the GitHub link, in the chat spaces. So check that out so you can check out all the good content there. All right, with that, thanks everyone for joining. Take care.
Bye.
Bye.